Hey y'all, I want to show you how to solve problems pertaining to implicit differentiation. So implicit differentiation is the procedure of differentiating an implicit equation, which I have up here in the white font, with respect to the desired variable, which is the letter y, while treating the other variables, which is x, as unspecified functions. With implicit differentiation, you're typically going to deal with chain rule functions, right? So I do have a video on that if you're interested. So what does all this mean? Like, what did I just say, right? Basically what you're doing is you're isolating all of the dy dx into one side and everything that you labeled as not dy dx on the other side. You're going to figure out what is considered dy dx and what's just considered not dy dx. And in order to know that, you're just going to find the derivative of everything. That's it. That's all this is. So you're just basically finding the derivative. You're deciding if it's dy dx or if it's not. And then you're just going to throw all the dy dx on one side, everything else on the other. And that's pretty much all you're doing. Let me walk you step by step in how to do all this. So with every single one of these problems, you are going to use the template d dx. When you find the derivative, you're going to determine if it should stay d dx or if you're going to put a y up here on the top and turn it into dy dx. And I'll show you how to do that, like when to throw that y in there, when not to. So everything is basically going to get the same template with a little bracket. So let's get started here. By the way, in this video, I have 3 example problems. I'm going to show you this general problem here. The second problem is going to have the chain rule, so you can get acclimated to that. The third problem is an application question. It's basically a word problem. I'm going to show you how to decode parts of it so you know what it's asking you to do. Let's see. So with step 1, some people skip step 1. I'm going to do it. You're going to use that template, right, of that bracket, and everything on the left side of the equal sign you're going to put together, and then you're going to do a second d dx, and you're going to put everything on the right side together. That's just something I like to do. You don't have to, but it helps me stay organized. I'm simply repeating what I'm seeing in the white font. Equals d dx negative 4, right? Now I'm going to take step 2 is going to be I'm going to take every single term and give it its own housing. It's all going to get its own d dx and its own bracket. So this is a term, this is a term, this is a term, this is a term, and this is a term. A term is anything in between the x, it's in between the plus and the minus sign, and it's in between that equal sign. So I have 5 terms. So I'm going to get 5 little d dx with little tiny sets of brackets, right? So let me go ahead and start doing that. You're going to want to do this next step, this one right here, where every single term gets that, because the next step after this is you're going to find the derivative and you're going to decide if it stays d dx or if you throw that y up into it and make it dy dx. So it's going to come in handy. It feels tedious now, but it will come in handy. Y to the second minus d dx 5y minus d dx x squared equals d dx negative 4, right? So everybody got its own little housing. Now we need to find the derivative of every single one of these terms. Now here's 2 things you need to ask yourself when you determine which one gets the dy dx and which one does not, right? So you're either going to have d dx or you're going to have dy dx. You're going to determine which one that is after you find the derivative. There's 2 things you're going to ask yourself. The first one is, am I looking at the star of the show? And the second question is, did I mess with anything? Did I have to change it or adjust it? And if you answer yes to both, it gets a dy dx. How do I know what the star of the show is? This right here is the star of the show. This right here is the star of the show. You look at the top of dy dx, whatever is after that d, that's the star of the show. So what you're going to ask yourself is, when I find the derivative, am I looking at the letter y, and did I mess with the letter y, which means did I find its derivative? By the way, the question 2, which is did I mess with it, did I find the derivative, the answer is always yes. The first question is the most important. Is this the star of the show? And if you answer yes to both, then it gets a dy dx. Let's go through all of this together. So I have d dx, I'm just setting up my template, and I'm finding the derivative, which is 3y to the second. How did I know to do that? Well, let me erase this. We're using that formula n plus the letter you're dealing with, n minus 1. So you bring down the nth degree, and then whatever the nth degree is, you subtract it by 1. That's how I found the derivative here. So let's go ahead and ask ourselves, okay, I just completed the derivative, right? Okay, so question 1 is, am I looking at the star of the show? Let's see, the star of the show is y, so yes to the first question. And question 2 is, did I find its derivative? Did I mess with it in any way? Did I adjust it? Did I change it in any way? The answer is yes. Yes to both, so therefore, dy dx. Let's move on to the next one. I'm going to use my template. I'm going to put the brackets up, and I'm going to find the derivative. Okay, it becomes 2y. Now, do I put a y up here or not? Let me think. I have a 2y. Am I looking at the star of the show? Well, yes, I am. Did I mess with it in any way? Did I find its derivative? Absolutely, I did. So that gets dy dx. Let's do this one. This one's a little bit tricky. Let's try to do this one. D dx. Let me set up my template. And the derivative is 5 times 1, because my y becomes a 1. Let me see. Now, the question 1 is, am I looking at the star of the show? Well, gee, I don't know, Emmy. I mean, it was 5y, but now it's just 5, right? The y became a 1. There is technically no y anymore. I'm just looking at a 5. So, I don't know. I mean, is the star of the show here or not? I'm not sure yet. I'm going to put a question mark on that. Let me move on to the next question. The next question is, did I mess with y in any way? Did I mess with the star of the show in any way? Well, I did find the derivative, so absolutely yes to the second question. The second question is always going to be yes. So now it's back to the first question I put a question mark on. Did I look at the star of the show? Am I looking at the star of the show? It's the letter y. I just don't have it. I just have a 5 only. So does it get a dy dx, or does it stay d dx? Well, it gets a y. It gets a y. It is dy dx. Why does it get a y? Because you were looking at the star of the show. It just happened to be when you performed a derivative, it happened to disappear and become 1, right? A derivative of y is 1. So yes, it gets 1, right? This is why it's important. This right here, this example is why it's so important to give every single term the template d dx. I know it's really easy to skip it because you feel like, okay, I don't need it. I kind of got this down. But the thing is, if you did not do d dx, you'll look at this, glance over, and go, oh, there's no y here. It's just d dx. But it's not just d dx. It's actually dy dx. And you're going to get the problem wrong. So this is why it's important to pay attention to the small details and to trust the system. So this one is in fact dy dx. Just because the y is missing doesn't mean that we ignore the reality that y is still the star of the show. Let's do this next one. I have d dx. I do my brackets and it becomes 2x. Well, let's see. Question 1 is, am I looking at the star of the show? No, I'm not. X is not the star of the show. Y is the star of the show because the problem told me it's the star of the show. And question 2 is, did I mess with this in any way? Well, yeah, I did. I found its derivative, but it's not the star of the show. I did not get 2 yeses. I only got 1 yes. Therefore, it stays d dx. I get to move on to the next problem, or term, I guess. I have d dx, my template I set up. I'm going to set up my brackets, and I'm going to find the derivative. I have a -4. What is the derivative of -4? It's a 0. -4 is a constant. A constant is just any number hanging out by itself. There's no alphabets touching it. It's just naked by itself. So when you find the derivative of a constant, which is the -4 right here, it becomes 0. So let's see. Am I looking at the star of the show? When we look at the star of the show, we're looking at this. Am I looking at the star of the show? I'm looking at this line. Let's see. -4. There's no y. I'm not looking at the star of the show. And question 2 is, did I change it in any way? Did I mess with it in any way? Did I find its derivative? Yeah, I did. But it's not the star of the show. So it gets a d dx. Right? So these are all 5 of the terms. I was able to determine what is considered dy dx by asking those 2 questions. Am I looking at the star of the show? Did I adjust or mess with or do anything to the star of the show? And if the answer is yes to both, it gets dy dx. Now my next step is to take all the dy dx and put them together, and everything that's not dy dx goes on the other side. Because I'm running out of room, I think what I want to do is rewrite everything. So let me just go ahead and rewrite everything. dy dx 3y to the second plus dy dx 2y minus dy dx, that was just a plain 5, minus d dx, right, because we only had a few of the dy dx, equals d dx 0. I literally just rewrote it, right? I haven't done anything extra yet. So my next step is to take all the dy dx and put them together, and everything that's not dy dx is going to go on the other side. So this is dy dx, this is dy dx, this is dy dx. This is not, this is not. So these are all going to go on the right. These are all going to stay on the left. So I have dy dx 3y to the second plus dy dx 2y minus dy dx, which is 5, equals, right, this right here, I'm going to move over. It's going to be the opposite sign. So I have positive d dx 2x. And then let's keep this one too. D dx, I have a 0. Great. Now what I'm going to do is factor out. I'm factoring out all the dy dx because our goal was originally to find dy dx. We identified what is considered dy dx and what is not considered dy dx. Now I have to find dy dx, which means basically isolate it. So I'm trying to contain all the dy dx and reduce it so I could throw everything over. So let's go ahead and do that. I'm going to factor out dy dx, parentheses 3y to the second plus 2y minus 5 equals 2x. I got rid of d dx because I actually don't need it at all, and that 0, I certainly don't need that. So I just have 2x now. I kept dy dx because we have to, right? It's asking me to find it, so I can't get rid of him. The other guys, we actually don't need. So I have dy dx. The next thing I do, I'm like one step away from solving the problem. I'm just isolating dy dx because when the problem says find something, you're just isolating. Right? That goes away, that goes away. So I'm left with dy dx equals 2x over 3y to the second plus 2y minus 5. This whole entire thing, this is the answer. So all we did for this problem right, is, let me grab a new pen. All we did is find the derivative right here, right? These are all the derivatives. All we did is find the derivative, and then we asked those two questions. Am I looking at the star? And did I mess with it in any way? And if it was yes to both, it means it becomes dy dx. If one of these is a no, that means it becomes d dx. So all I did is find the derivative of every single term, and then I asked those two questions. Based on the answer of those questions, I decided if it was dy dx. Then all I did is just isolate all the dy dx together. Everything that wasn't went on the other side, and then I made dy dx be all by itself on the equal side. On the left side of the equal sign. And that's it. That's all I did. Find the derivative, ask those two questions. Is it the star? Did I mess with it? And then you're going to start isolating dy dx. Super easy. So here's what's up. You're going to deal with chain rule in a lot of these problems, right? So let's do a problem where it's the exact same setup. You're just finding the derivative, and then you're going to decide if it's dy dx. How do you know you're looking for y? The star of the show is always at the top, okay? And then we're going to basically isolate dy dx like we did earlier. The only difference is we're going to use chain rule this time. So I am seeing a square root right here. We got to get rid of that. You could keep it, but it gets tricky. I'm just rewriting the problem. We're not doing any math right now. Let's see. Square root of xy is going to be parentheses xy positive half, right? If my problem gave me a fraction, it looked like that with the 1 in the numerator, and then that square root xy was in the bottom, and it asked me to get rid of that square root, what I would do is I would do x, y in parentheses negative half, right? We don't have a fraction, so ours is positive, right? I'm going to do an equal sign, x squared times y plus 1. I'm just rewriting it. This whole thing is simply rewritten, right? It's all of this rewritten. So let's do step 1. Let's circle step 1. And some people skip it. I don't. We're going to do the template d dx. Everything on the left side gets its own bracket. Everything on the right side of that equal sign gets its own bracket. We're doing positive, like we mentioned earlier. D dx. Let's see, I got x squared y plus 1, right? So we're going to end up with 3 terms, right? So this is a term, this whole thing is a term, this is a term. I'm going to have 3, step 2, I'm going to have 3 of the templates and 3 little bracket sets. Half equals d dx x squared times y plus d dy with a 1 as our constant, right? And we need that. We need that so we can understand if we need to throw a y in there or not in our template specifically, right? As we find the derivatives. So here's the thing. I'm looking at the first term right here. This is term 1, term 2, term 3. I'm looking at term 1, and I'm actually looking at term 2, and we're going to use product rule, right? So that's basically, so if you're multiplying 2 things together, if I'm multiplying x and y together, that means I'm going to end up with fx g prime x plus gx times f prime x, right? A more cleaner version is if I'm multiplying 2 guys together, right? Which is exactly what I'm doing right here and right here, right? If I'm multiplying 2 different little alphabets together, and I have to find the derivative. I have to use product rule. And with product rule, it's a b prime plus a prime b. What does that mean? Well, that little prime thing right here, that's the little stick thing I drew, that just means you're going to find the derivative of this little alphabet. You're going to leave the other ones alone, and whatever has that stick thing, you're going to find its derivative. The other ones, you don't mess with it. Which means one term, which would have gotten that d dx, you're going to have two d dx's now. This one's going to get a d dx, and this one's going to get a d dx. So we're going to end up with a bunch of little d dx's. Okay? Let me actually keep what I just had. We're going to do a prime plus a. Okay, great. That's what we're messing with. We still have to follow the composition function rules. So let's go ahead and do that. We're going to walk through every single one. Let's do the first set first, and we'll walk through it. So we're doing f of g. So f is on the outside, so that becomes half xy with the nth degree of negative half. Right? Then we're going to do the g part, the inside part. And that's going to be x times y. We're doing x times y. So that's the product rule, right? That's the g. We were doing f and g, so that was the outside. This is the inside. Out, inside. I just messed with the outside. I didn't touch the inside. Now I'm going to touch the inside. Cool. So I'm going to leave a as it is, right? A and b, I'm following this right here. I'm going to leave a as it is, which is x. And I'm going to find the derivative of y, which becomes 1. And let me give it its own d dx, because we're going to need that. So back to what I said, we're going to leave x as it is, and I'm going to find the derivative of y. Plus, I'm going to do the second part, right, which is a prime b. I'm going to find the derivative of x, and I'm going to leave y as it is. I want to keep these organized for you. I have a habit of not doing that. Y, okay? I left x as it is, and then I left... Okay, great. So this entire thing, this whole 3-step thing, is this entire problem. But they all get their own dx template. Now it's up to us to determine if it gets a y at the top. So let's see, the first one right here, does it get a y at the top? Well, no, it doesn't. I never touched y. I left y as it is. So no, it stays dx. What about the second part? I don't see a y. But the thing is, I did in fact have a y originally. I was looking at the star of the show, and yes, I altered the star of the show. So absolutely. What about this last one, dx? Well, I'm looking at y, but it's not the star of the show. It is the star of the show, but not here. Not here, it's not the star of the show. I'm looking at a y, but it was originally x. X is the one that was the center focus here. So no, it doesn't get one. It stays dx. See, these kind of get a little bit tricky. You have to kind of pay attention. Right, so let's move on to the next one. I have an equal sign, right? I'm right here now, and I'm going to use this part now. So we have product rule again. So I have dx. We're going to have something here plus dx, and I'm going to have something here. Let me get rid of that for us. All right, and we're following this A-B format. So let's see. I'm going to find the derivative of x, and I'm going to leave y as it is. So let's see. Does that get a d dx or does it get a dy dx? Well, am I looking at the star of the show? The star of the show in this case is x. So no, I'm not looking at the star of the show. So no, it doesn't. It stays d dx. What about here, the second part? I'm going to keep x as it is, and I changed y to 1. Well, yeah, I'm looking at the star of the show, so it gets a y. Absolutely. So it gets a little bit tricky, you know. Let's do the plus sign thing, because we're moving on to the next part, which is right here. And we have a constant, which becomes 0, and because we're not looking at the star of the show, it becomes d dx, right? So here's the thing. We could start circling what's dy, dx, and what's not and start adjusting and moving things over, but there's one more step we have to do for this particular specific problem, and that's right here. Let me grab a different color. This right here, this problem that we expanded into 3 parts, because we had to, this is f, and this whole thing is g. We have to distribute. I have to put this into that and into that. So it might change. It might change the dynamics of what is considered x. I mean, not what's considered dy dx and what's considered d dx. So let's go ahead and do that. So I'm going to do d dx again, and we're going to put it all together. So I'm putting this together and this together. So it's going to be half 1 over square root of x y. And that was from up here earlier. Remember how we were kind of trying to figure out if we had a fraction, what would it look like? Well, we have that fraction, that exact same thing. So I turned it into what you're seeing up there. And we're going to multiply that by x. Anytime you're getting a fraction and you're multiplying it against a whole number or even like a whole letter, you're going to put that invisible 1 underneath. So does this become dy or dx? Does it become d dx or does it become dy dx? Well, this is going to get dy dx. The only reason is because we have one right here. Anytime you put a dy together with anything, it magically turns into dy dx, right? So that one we can get rid of. We're going to do a plus sign, and we're going to do the same thing, d dx, and we're going to try to figure out what it gets. I'm just putting together the first 2 parts, and then I'm going to multiply it by y over 1. Does it get d dx or dy dx? Well, they're both d dx. There is no y, so we just keep it as is, right? So we got rid of that, we got rid of this, we got rid of that. We're going to do the equal sign. We're going to do d dx 2xy plus dy dx, which is x to the second, and we can leave this out because it's a 0. We're not going to mess with it. Great, perfect. So we already distributed everything, right? And the next thing we're going to do is we're going to put all the dy dx together, and we're going to put all the non-dy dx together. So we can do that as well. I'm kind of running out of room, so I think I'm just going to move it over to the next page. I'm just going to rewrite exactly what I have. Dy dx. I had that half times 1 over square root of xy times x over 1 plus d dx, which was half times 1 over square root of xy times y over 1 equals d dx. What was it? 2x y plus dy dx x to the second. And we left out that 0. Great. So we're just going to put all the dy together, and we're going to put everything else on the other side. Let me see what I have for dy. This whole thing is dy dx, and this whole thing is dy dx. Everything else is going to go on the right side. So let's go ahead and do that. I have dy dx, and I'm going to scrunch them together. So what I end up with is 2x square root of xy. I just pushed all three of these together, all of these, right? Minus dy dx, which is x to the second. Use that. I used that. I'm going to do an equal sign. D dx 2xy. Get rid of that. Minus d dx, which is going to be y over 2 square root of xy. Great. Y over square root of xy. Now all there's left for me to do is factor out dy dx. So I have a parentheses of 2 square root of xy minus x to the second equals 2xy minus y over 2 square root of xy. We can drop these, right? Once you start factoring out dy dx, you can drop the d dx. The final step is to simply isolate dy dx. So we're going to move all of this over. Let's go ahead and repeat it on this side. 2 square root of xy. There. That goes away. That goes away. I'm left with dy dx equals 2xy over y 2 square root of xy all over x over 2 square root of xy minus x to the second power. That's number 2. Great. This whole entire thing, all of it, this is the answer. So what we did is we gave every single term its own housing of d dx. Then I had to distribute stuff. I had to do the chain rule. I had to do outside function, inside function, and I had to decide what is considered dy dx. Then I just isolated all the dy dx on one side and everything that wasn't on the other side. And then once I figured that out, all I did is isolate dy dx for one final time, and I came up with the answer. The most tricky part is just knowing which rules to use when you have chain functions, when you have composition functions, when you're doing derivatives. So that's the most tricky part. So the third question, example problem, I guess, here is a word problem. Right, so this one's asking me to find slope. It says find the slope, right? And slope, if you remember, is x over y of the graph implicitly. Basically, this implicitly is just saying find implicit differentiation. Determine the slope of the tangent line to the graph. This is our equation right here. And we're going to do at points square root of 2, and it's going to be minus 1 over square root of 2. The points thing, we can ignore that for a little bit, but all it's asking you to do is find the implicit differentiation of this particular equation that it gave you right here. So let's go ahead and set it up. Step 1 is we're going to do everything on the left side with the term d dx, and everything on the right side with d dx. And then every single term is going to get its own. D dx x squared plus 4y to the second equals d dx 4. Great. This is kind of looking like example 1, right? Okay, so every single term gets its own d dx x to the second plus d dx 4y to the second equals d dx to the fourth. Great, 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 great. Now I got to determine if it gets dy dx when I find the derivative. And I got to look at two things. I have to look at, is it the star of the show, which is y? Y is the star of the show, right? Is it the star of the show? And is it being messed with in some way? So let's set it up. D dx is going to be 2x. And let's see, star of the show? Nope, it stays d dx. What about this one? I have d dx, and it's 8y to the first power, right? Because 4 times 2 is 8. Let's see, I am looking at the star of the show, and I did do something to it, so absolutely, dy dx. What about here? D dx, constant, what's a 0? So, you know, we don't put a y there because there's no alphabets. So now I need to put dy on one side and everything else on the other. So let's do dy dx, which is 8y, equals d dx, which is going to be negative 2x. Great. I have to isolate dy dx. dy, well, let me do it in the more traditional way. 8y, 8y. We can get rid of those, and it gives me dy dx equals 2x over 8y. We can reduce that further, right? I mean, this could technically be the answer, but we can reduce it further. How many times does 2 go into 8? It goes in 4 times. So I am left with negative x over 4y. This is the answer. However, we still have to worry about these points, right? So what do I do? Well, I have x here and y here, right? Because that's how it's set up, the points. So what I'm going to do is I'm going to find slope by inputting the square root of 2 for x and negative 1 over square root of 2 for y. And what does that look like? That's going to look like this. We're going to do negative square root of 2 over 4, and that's going to be negative 1 over square root of 2, which gives me negative square root of 2 over negative 4 square root of 2. I just combined it together. Now, I mean, you could make this the answer, but we can simplify further. So let's go ahead and find the reciprocal, right? So if you want to reduce all this fraction stuff, you do the opposite. It's division, so we're going to multiply. What's that look like? Well, I'm going to do negative square root of 2 times that invisible 1 times negative square root of 2 over 4, right? Now, what does that give me? Well, we have 2 negatives, so 2 negatives make a positive, and then 2 square roots of the exact same thing makes the hat get ripped off, and it becomes a 2. It just becomes a 2. But it's a positive 2 because I have those 2 negatives. And then I also have that 4 in the bottom because 1 times 4 is 4. And it's positive. And if I reduce that, it becomes half. So the answer is half. The slope of this problem, this equation right here, is half. So that's how you find implicit differentiation problems with slope if it's just like a word problem with a bunch of like words in it. It's called an application question. Okay, I hope this helped. It was kind of long. Okay, thanks guys. I mean, I guess I should probably mention I have a sticker shop. If you guys are interested in stickers, check it out if you want. No pressure. Okay, thanks. Bye.